This lesson is about geometric sequences. The learning target, I can identify geometric sequences and find the common ratio. We have looked at patterns before. We have learned that a sequence is a pattern. However, if it is a geometric sequence, it is a multiplication pattern. So, geometric sequences, multiplication pattern. Our first pattern is listed 24, 12, 6, 3, 3 halves, 3 fourths. And we have to find what's called the common ratio and make sure this is a geometric sequence. So, is this a sequence of numbers formed by multiplying to get the next number? And if we multiply, are we always multiplying by the same number every time? 24 times what number would give me 12? 12 times what number would give me 6? 6 times what number would give me 3? So if I think of this algebraically, 24 times what number would equal 12? Well, I would undo the multiplication. And I know that if I simplify my fraction, 12 over 24 is equal to 1 half. So we have our common ratio of 1 half. If we multiply 24 by 1 half, we do get 12. Now let's check and make sure this works for all of them. If we multiply 12 by 1 half, do we get 6? If we multiply 6 by 1 half, do we get 3? If we multiply 3 by 1 half, do we get 3 halves? And if we multiply 3 halves times 1 half, do we get 3 fourths? We do to all of those. So our common ratio is R, and R equals 1 half. And if I had to find the next number in the pattern, if they asked me to find the next number or the next term, I would multiply 3 fourths times 1 half, and that would equal 3 over 8. If I needed the term after that, the term after that would be 3 over 8 times 1 half, which would equal 3 over 16. So let's take a look at another problem. This time our pattern is 1, 2, 4, 8, 16, 32. So again, we ask ourselves, if this is a geometric sequence, it will be a multiplication problem. That means I would multiply by a number by 1 to get 2, multiply 2 by a number to get 4, multiply 4 by a number to get 8, etc. So that common ratio, that R, means that 1 times some number must equal 2. And if we haven't already figured out what that number would be, obviously x would equal 2, which means my common ratio is 2. So the next term after 32, well, 32 times 2, 64. And the term after that, that would be right, 64 times 2. For our next pattern, we notice that we have alternating minus signs, alternating negative signs. Positive 3, negative 6, positive 12, negative 24, positive 48, negative 96. We ask ourselves, is it a geometric sequence? Is this a multiplication pattern? Again, we can set this up as 3 instead of x, must equal negative 6. So, if I solve for the common ratio, I get negative 2. Now let's check and make sure that this is a geometric sequence and that I can obtain every one of these numbers multiplying the previous number by negative 2. 3 times negative 2, I'm good. Negative 6 times negative 2, I'm good. 12 times negative 2, I'm good. You try the rest. So it is a geometric sequence. The common ratio is negative 2. How would you find the next term? And if you said 192 times negative 2, you would have been correct. And that would, of course, equal negative 384. One more. This one has a lot of fractions in it. And I know that a lot of you are not happy with fractions. It also has alternating negative signs in it. So let's check and see, does this work? Is there a number as a common ratio times 40 that equals negative 10? Well, I could solve for this by dividing by 40. And r equals negative 10 over 40. That fraction does reduce. Negative 10 is divisible by 10. And 40 is divisible by 10. So that would actually equal negative 1 over 4. And I do need to check to make sure that this is a geometric sequence. So ask myself, is negative 10 times negative 1 over 4 5 over 2? And then I check the next one. Is 5 over 2 times negative 1/4 negative 5/8? Is negative 5/8 times negative 1/4 5 over 16? Is 5 over 16 times negative 1/4 negative 5 over 32? What did you come up with there? I said that it does work here and it does work here, but 5 halves times negative 1/4 is negative 5/8, so we're good here, times negative 1/4 is 5 over 32. So I actually missed this term. I went straight from here to here. So this is not a geometric sequence. Very important that we checked. If we would not have checked, we would have come up and said we had a common ratio, but it wouldn't have actually worked.